mathematical proofs, and in number theory, you should know how to prove a theorem using induction. Induction basically is ran out using two easy steps. The first one is to prove that the theorem works when n is equal to 1, and the second is to A, assume it works for n is equal to k, and B, prove it works when n is equal to k plus 1. So, let's try to prove this. Let's try to prove that the nth triangular number is equal to n into n plus 1 divided by 2 using induction. So let's follow the first step. Step 1 says that this theorem should work when t1 is equal to, when n is equal to 1. So the first triangular number is equal to 1, so that means that t1, or 1, is equal to 1 into 1 plus 1 divided by 2. And this is equal to 1. So it works, and step 1 can get a nice green check. Step 2 says that we now have to assume that it works when n is equal to k. So we should say that tk is equal to k into k plus 1 divided by 2. And now for step B, 2b, we must prove that it works when n is equal to k plus 1. So this works. Now we have to prove that it works when n is equal to k plus 1. When n is equal to k plus 1, we know that tk is equal to k into k plus 1 divided by 2 from our assumption over here. So let's substitute tk with k plus 1. So tk plus 1 is equal to k plus 1 into k plus 1 plus 1 divided by 2. And this is equal to k plus 1 into k plus 2 divided by 2. Okay? The next thing we have to show is that, well, we can assume that the next row in the triangular numbers will have k plus 1 more dots than the previous row. So tk plus 1 is also equal to tk plus k plus 1. So that means that it's equal to k plus 1 into k divided by 2 plus the extra dots, or k plus 1. So this shows that then we can say that these two equations are equal. So we can get that because tk plus 1 is equal to tk plus 1 using reflection, we can say that k plus 1 into k plus 2 divided by 2 is equal to k plus 1 into k divided by 2 plus k plus 1. Let's multiply both sides by 2 to get rid of that denominator. And we can see that then we get k plus 1 into k plus 2, which is equal to k plus 1 into k into plus 2 into k plus 1. Okay? And using distribution, using the distributive property, we can factor out k plus 1 since they're common factors of both things that we're adding on the other side. So we get that k plus 1 into k plus 2 is equal to k plus 1 into k plus 2. And so, since this is equal, we can now say that tk plus 1 is equal to k plus 1 into k plus 2 divided by 2. So, going back to our checklist, we can now give our third and final step a nice big green check. And we have totally proved that the triangular number theory works using induction.